Quick question. What if the sky you're looking at right now used to look completely different? Not different weather, not different clouds. I mean literally different objects hanging up there, things that simply aren't there anymore. Gone so long ago that nobody alive has ever seen them and nobody ever will. Hi, I'm Potato, and today we're talking about one of the strangest ideas in modern astronomy. The theory that Earth might have once had two moons instead of one, and that one of them didn't drift away or get destroyed in some dramatic explosion. It just quietly, slowly, crashed into the other one, and became part of it forever. If that sounds as wild to you as it does to me, go ahead and hit subscribe, because we've got a lot more of this kind of cosmic mystery coming your way. Okay, let's get into it. To understand this theory, we first need to talk about something that's been bothering scientists for decades. A mystery hiding in plain sight on the surface of our actual moon. If you've ever looked at the moon through a telescope, or even just really carefully with your own eyes, you've probably noticed the dark, smooth patches spread across its face. Those dark patches are called Maria, which is Latin for seas, even though there's no water there at all. They're actually enormous plains of ancient, solidified lava, formed billions of years ago when molten rock flowed out and filled in giant impact basins, then cooled into smooth, flat, dark stone. Here's the strange part. Nearly all of those smooth lava plains are on the side of the moon that faces Earth, the side you can actually see from your backyard. But the far side of the moon, the side that always faces away from us because the moon is tidally locked to Earth, looks completely different. It's covered almost entirely in rugged, mountainous, heavily cratered highlands, with barely any of those smooth, dark plains at all. Same moon, same rock, same overall age, but two wildly different faces, like it's wearing two different masks. For a long time, this asymmetry puzzled scientists. Why would one half of a single object be so smooth and dark, while the other half is so rough and pale? It's not like the near side and far side experienced different amounts of sunlight or different gravity from Earth in any way that would explain something this dramatic. Something else had to be going on. Something in the moon's deep, ancient history that shaped its two halves in completely different ways. This is where the two-moon idea comes in, and it comes from a pretty clever piece of computer modeling done by planetary scientists trying to recreate the early solar system. Here's the setup. Most scientists agree the moon we see today was formed roughly 4.5 billion years ago, shortly after a Mars-sized object, sometimes nicknamed Theia, slammed into the young Earth. That collision blasted an enormous amount of debris into orbit around our planet, and over time, gravity pulled that debris together into the moon. But here's the twist some researchers proposed. What if that same violent collision didn't just create one moon? What if it created two? A large one and a smaller companion moon, both forming from the same debris cloud, both orbiting Earth at roughly the same distance for a while. In this scenario, the smaller moon would have been maybe 1/3 the diameter of the main moon, similar in size to some of the larger moons orbiting other planets in our solar system today. For a while, in this theory, Earth would have had a genuine double moon sky. Two moons orbiting closely together like that, though, tend to be unstable over long periods of time. Gravity is complicated, and orbits like this can slowly drift and shift. Eventually, according to the model, the smaller companion moon's orbit would have started to destabilize, slowly drawing it closer and closer to its larger sibling. And because the smaller moon was moving relatively slowly compared to something like a typical high-speed asteroid impact, when it finally did collide with the larger moon, it wouldn't have been a violent, explosive crash that blasted rock and debris everywhere. Instead, computer simulations suggest it would have been a surprisingly gentle collision, all things considered more like a slow, cosmic splat than an explosion. That's actually the key detail that makes this theory so compelling. A slow, low-speed impact like that wouldn't create a fresh crater and scatter debris into space. Instead, the material from the smaller moon would essentially pancake itself onto one side of the larger moon, adding an extra thick layer of solid crust to whichever side got hit. According to the model, this is exactly what would explain the strange asymmetry we see today. The side that absorbed the impact, now the moon's far side, ended up with a thicker crust. And that thicker crust, being harder for later molten lava to push through from underneath, meant far fewer smooth lava plains could ever form there. Meanwhile, the near side, with its thinner crust, allowed magma from deep inside the moon to break through much more easily, filling in impact basins and creating all those smooth, dark seas that face us every single night. In other words, according to this theory, The two very different faces of the moon aren't just a coincidence. They're basically a fossilized record of an ancient collision, frozen in stone for billions of years, hiding in plain sight the entire time humans have been looking up at the night sky. Now, to be clear, this isn't a proven, settled fact the way something like gravity or the shape of Earth is. It's one leading scientific hypothesis among a few competing explanations for the moon's asymmetry, and there's ongoing research and debate about exactly which model fits the evidence best. But what makes the two-moon idea especially compelling is how well it lines up with real data, particularly measurements of the thickness of the moon's crust taken by orbiting spacecraft, which do show the far-side crust is noticeably thicker than the near-side crust, exactly matching what this pancake collision model would predict. Let's just sit with that idea for a second, because it really is strange. If this theory is correct, there was a period in Earth's earliest history, less than 100 million years after our planet even formed, when anyone standing on the surface, if there had been anyone there yet, which there wasn't, would have looked up and seen not one, but two moons hanging in the sky, orbiting close enough to each other that their gravitational relationship was already unstable. And instead of ending in some world-ending collision, complete with fireballs and shattered rock flying everywhere, it ended quietly. A slow, gentle merger. One moon absorbing another, the smaller one essentially becoming a permanent, one-sided scar on the surface of the larger one, hidden for eternity on the side facing away from Earth. We only ever see one face of our moon precisely because it's tidally locked to us, always showing the same side, month after month, year after year, for as long as humans have existed. Which means for the entire history of human civilization, every single person who has ever looked up and admired the moon has only ever seen half the story. The lopsided, scarred, mountainous truth has been quietly facing away from us this entire time, invisible until spacecraft finally flew around to the far side and photographed it directly. Kind of incredible, honestly, that something this dramatic, an ancient sibling moon slowly folding itself into our current moon, could leave a permanent fingerprint lasting over 4 billion years, and that fingerprint was sitting right there the whole time, quietly facing away from every single person who has ever looked up at the night sky. Thanks for hanging out with me today. If your brain enjoyed uncovering this hidden lunar history as much as I did, stick around, because the universe has plenty more secrets like this hiding in places we thought we already understood completely. I'll see you in the next video.